Alright, so this is my attempt at an instructional video on doing some basic coding with Siemens STL. We're using TIA Portal version 16. I've got this running on a VM, so it might be a little slow. But at this point I've written this debounce block, and I've written in ladder, and we're going to try to replicate this in STL. So what we do with this block is we have a raw input, we have a set delay time, a reset delay time, and a debounced input. We take the input, and it has to be on for 5 seconds in order to turn on the debounced input, and it has to be off for 3 seconds to turn the debounced input off. So the logic looks like we've got one rung with a timer on. We've got one rung with a timer off. And then we've got this little rung to do some logic in there. So if I turn on the input, give it our 5-second delay, and our debounced input came on. And then when I turn it off, after our 3-second pause, we lose our reset delay timer output, and that makes us drop our debounced input. And then if we blip it, we don't turn on our output here. So let's take a minute and talk about RLO. And this is in the Siemens ladder manual and in the STL manual. So if you try to think of RLO as the green power moving down the rail here, or along the rung, we've got power coming into this raw input, but because our contact isn't closed, our RLO drops past it. We've also got this parallel branch, and we've got power coming in, but because we don't have debounced input, everything is dropped out after that. When we turn on our input, now RLO is made, and once our timer is made, it'll allow to continue. And then this output right here takes the RLO and writes it to this variable right here. Then when I turn off the input, the RLO power is allowed to flow through here. Whenever we dropped out our timer here, then it dropped everything out. So the RLO is important to keep track of when using STL. So let's make a new block. We're going to make a function block, and we're going to write it in STL. And we want to call it debounce STL for today. Okay. Everything in the interface I'm going to make just like the other one. Okay, so our first network is going to be our timer on network, and I want to call timer on. I'm going to tell it to do a multi-instance. I'm going to tell it to use set delay. Okay, so let me bring up that other one. Let's talk about this for a second. This is our first rung. So in the same way that we have a timer here, this is our timer. And if you notice, we have in, and we have an in here. So we're going to take, and we're taking raw input and putting it into our in. So let's take our raw input, let's put it right there. And our PT, our preset time, we're going to drag it right there. Now this, as far as I know, this rung is, these two rungs are identical. And that's all we had to do there. Okay, we're going to close that. Let's make a new rung. Okay. Call TOF. We're going to use one of our defined instances, and this one is the reset delay. Just out of paranoia, did I put the right one in the first run? Set delay, reset delay. Timer, we're still going to use our raw input. PT, we're going to use reset delay time. Okay. Now comes the somewhat tricky part, the hardest part of this whole thing. Okay. Whenever you go to write this type of logic here, just think of it in the name of the mnemonics and what you're logically doing. We are saying and raw input. We're taking the RLO and the raw input, doing some Boolean expression, doing some Boolean math. So we're going to say and raw input. And to help us remember, we'll put it over here. And raw input. Whenever I started working with STL a couple years ago, I had to do this for every step or every instruction until I got it down and I learned. Okay. Once we've evaluated that, we're going to take the RLO and set delay timer.q. And set delay timer.q. Okay. And what that does is it equals, we're going to take the RLO and write it to debounced. Yeah, I got to put a space in there. It's going to get mad at me. Okay. So this is the same. These three lines here are the same as this top rung. Top of this rung, but we've got this parallel branch here. So what we're going to do is we're going to give it some space, and we're going to say or. That's what we're saying. We're saying these conditions or these conditions. So or and debounced input. This is and not raw input. Then and reset delay timer dot q and okay. So now these three conditions are these three conditions here. No. Yeah. let's read through this a little bit, because when we read this, it's going to make a little bit more sense. And raw input and set delay timer. And raw input and set delay timer and debounced input and not raw input and reset delay timer equals debounced input. So you can kind of read them back like that. So let's compile this. And then let's go back to our OB1. Let's make a new run. And let's put our STL block in there. Let's use the next input. Input 0.1. We can use the same time. Now let's send this to the PLC. And let's see what we get here. Turn it on, and we wait. We turn it off, and we wait. Let's blip it. Okay, seems like it's working. So let's open it up and let's see what we got going on in here. Let's go network by network. First network. So here we're tracking the RLO, and we can see that in this first run it's false because our input's false. So if we turn it on, it becomes true. Okay, that makes sense. Again, on the second network, we're turning on our raw input and then we're turning it off. Okay, now let's look at this third one. This is what you'll see in the field. More work with more. So what we're going to do is we're going to watch the RLO and watch it move down. So let's turn it on. Okay, so what we've got here is we've got our raw inputs turned on, which it is, and then our timer waited for 5 seconds and it turned on the output. Let's skip over this just for a second because this is all the parallel branch. And we turned on our output. Then, whenever I turn it off, we have these conditions. And then it turns on our debounced input. We had our debounced input was on. We didn't have our raw input. We had our reset delay timer had its output on. So therefore, we could write that out. We turn on, this comes on, and then it lets the output come on. Whenever we turn off the input, these conditions come on and allows the input to come on. So, a lot of times when you're troubleshooting something, you'll be in the field, just track the RLO. Just watch it as it moves down and see what's going on. And, if your end goal is to turn on an input, you need to make sure that all of your required conditions to turn on that input are on. So, I think we're good with that. I think for the next video, what we'll do is I'll show you what the equivalent would be in ladder so that we can see if everybody's on the same page or if they like that. Maybe I want to verify that this set delay time isn't a bogus value. I want to say that it's greater than or equal to 0 milliseconds. So we'll write some logic like that in a STL with some loads and transfers to do that. I hope this was informative. Give me a heads up if you need anything more explained or any suggestions on how to do stuff better or different, and we'll see where that gets us. Thanks for watching. Bye.